You may have heard of Lumina before, or maybe you haven't, because Lumina Image 2 was released in February 2025, almost a year ago as of time of recording, to practically no fanfare. It's a lighter weight model that runs on as little as 8 gigabytes of VRAM, and it was made as a lightweight response to the heavier and heavier models that kept coming out in 2024, like Flux and Stable Diffusion 3.5. It's a good idea, but it never really took off. It never really got widespread adoption, probably mostly because Stable Diffusion XL is the direct competitor in its weight class, and XL is still pretty good for its age. But that didn't deter people from trying the new architecture. In about 5 months after release, NetaLumina came out, which is an anime fine-tune. This effort was continued in the form of NetaYume Lumina, and a separate fine-tune called NewBie emerged in December 2025, which brings us to the topic of today's video. I've been playing with NetaYume Lumina and NewBie for about a month, and I'm just going to tell you what I think about these two models. So first of all, here's my understanding of the phylogenetic tree, so to speak. These are both anime fine-tunes, but to my understanding, they are completely unrelated and have been trained separately. Functionally, I consider the Neta branch to be closer to the original Lumina. It functions about the same in terms of prompting. You use plain English sentences. NewBie is completely different. It expects its prompts in XML, and in their blog post, they do talk about trying to maintain the same spirit of prompting as Stable Diffusion XL fine-tunes like Pony and Illustrious, like composing your prompt as a list of Dambaroo tags. So yeah, two completely different philosophies for these two different versions of Lumina. Before we talk about the images themselves, let's talk about performance. There are reports of people running these on as little as 8 gigabytes of VRAM, but probably you're going to want something more like 16 to 24 gigabytes. These models are heavier than Stable Diffusion XL, but not as heavy as things like Flux. I've done a benchmark of generation time at various resolutions. These benchmarks were done on a Ryzen AI Max 395. It's not a very fast processor. It's maybe about half as fast as a 6800 XT, but it does have a lot of VRAM. And for comparison, I've run Stable Diffusion XL and Chroma Radiance so that we can get an idea of relative performance. So first, let's just take a look at raw generation times. If you're used to Stable Diffusion XL, you might be disappointed with how slow this is. And if you're used to things like Flux, you might be pleasantly surprised with how fast it is. I'm doing 30 steps here, which is about standard. You can go down to as little as 20, I think, and get away with it. And there are lightning LoRa's that let you do maybe 8 steps or 4 steps or whatever. But just for apples-to-apples comparison, we'll stick with 30. And it is taking me a minute or two to generate the image. Let me get rid of Chroma Radiance just so that we can see the lower end of the graph a little bit more clearly. On the bottom is SDXL, it's the fastest, and we can see that NetaYume is actually faster than NewBie. But to get a better idea of what this looks like, let's just take the number of steps divided by 30 so that we can get inference time per step. Now, keep in mind this does include VAE decode, so it's not just the time it takes to do one step, it's the time to do the whole process. And again, I'll get rid of chroma so that we can see the rest of the graph a little bit more clearly. And by the way, the image sizes that we're dealing with range from 768 by 768 to 2048 by 2048. Really, the image sizes that you're going to be using for this are at the middle of the graph. And you would use the upper end of the resolution for processing upscaled images. And you wouldn't use as many steps processing the upscaled image as you would during main text-to-image inference. But anyway, it's worth noting that image generation time versus resolution is not linear, it's exponential. That's not as noticeable for something like Stable Diffusion XL because generation times are so fast, but you do start to notice that curve on Lumina models. But if we take the average of the iteration time of the middle of the graph, conveniently that comes out to approximately 1 iteration per second on Stable Diffusion XL, and that gives us a nice speed factor for comparing all 4 of these models. So we can see here that SDXL is approximately 1, and it takes NetaYume approximately 3 times longer to generate the same image. And it takes NewBie approximately 4.5 times longer, and it takes Chroma Radiance approximately 13 times longer. Or to put it another way, NetaYume is approximately 4 times faster than Chroma Radiance, and NewBie is approximately 2.8 times faster. And with the Lumina models compared to each other directly, NetaYume is approximately 1.5 times faster than NewBie. So yeah, all that to say that these models basically split the middle between SDXL and Chroma. Now, before we get to our direct comparisons, let's talk a little bit about NewBie's XML formatted prompting. It's certainly a strange choice when the norm is plain English sentences. I think the rationale here is that it helps with a more precise layout, and it kind of bridges the gap between plain English sentences and datasets like Dambaroo that are just a collection of tags. It's certainly a strange way to prompt, and if you're using the raw Comfy UI interface, it feels like it's missing a front end that would help you with the formatting. There is an attempt at a front end called NewBie Image Generator. You might want to check that out in case you're interested in exploring NewBie for yourself. Now, with a little bit of manipulation, I was able to make it accept plain English prompts. I was able to do this because the text encoder input is actually Gemma. It's a programming LLM. So I was able to finagle the system prompt a little bit to make it accept plain English inputs and reformat them as XML. I would like to emphasize that this is not the intended way to use this model, but it does allow me to use the same prompt for both NewBie and NetaYume so that I can do direct comparisons. And that brings me to my first method of evaluating these models, which is to generate a bunch of images in batches and just see what we get. And like any normal crazy person, I've set up an LLM to generate prompts for me. This allowed me to run this thing unattended for a week just to see what it would generate. Now, of course, these are not optimal prompts, but the sheer volume of images I could create using this method was informative, at least for noticing overall patterns. And the first thing I noticed is that NetaYume is very prone to letterboxing. What I mean by letterboxing are black or white bars along the edges of the image, usually the top and bottom. At first, I thought this was an aspect ratio problem, like I was generating images that were too wide, but this appears to occur at any size, at any resolution, at any aspect ratio. Trying to address it with the negative prompts doesn't really seem to help either. So my conclusion is that it's just a quirk of the model. And along those same lines, for NewBie, it wants to generate a lot of text, artist signatures, titles across the top, text boxes. And again, negative prompting for this doesn't really make it go away. And NewBie also seems to want to generate character reference sheets. Generally speaking, they're images of the character that are sketches with multiple perspectives. And this propensity to generate signatures and reference sheets might have something to do with specific artist tags. So if certain artists have prominent signatures or a lot of their work is character references, that is going to be reflected when you use an artist tag like that. And artist tags seem to be important for NewBie prompts. I've tried generating things without artist tags, and everything seems to come out like a crayon drawing. Overall, it's a tough model to wrangle. Another thing I've noticed with both models is hands. Hands are pretty bad. This is particularly noticeable for me because for SDXL Illustrious, hands just aren't a problem anymore. But some of the hands generated by these Lumina models are so bad they can't even be fixed. So if I had to pick a weakest aspect for both models, I would say it's this. In addition, NewBie seems to be overall worse for anatomy. NetaYume has its share of problems too, but if we're counting extra limbs and extra feet and just kind of misshapen bodies and stuff, I think NewBie has a higher rate of those mistakes. But I think both models suffer from bad anatomy at higher rates than SDXL Illustrious. And another thing I've noticed on both models is composition sometimes is a little bit awkward. Sometimes objects mentioned in the prompt look like they've been copy-pasted on top of the image instead of blend into the environment. For instance, in the top left, the prompt mentions a raven supposed to be perched on somebody's shoulder, and on the right, there's a woman supposed to be standing on a roof. It's like it took an image of woman standing and an image of roof and then just pasted two separate images together. But I don't want to come across like I only have bad things to say about these models. I've deliberately front-loaded most of my criticisms so that I can spend the rest of the video focusing more on getting good results. For instance, I think they can do scenery pretty well. As we can see here, these are a mix of both NetaYume and NewBie on just random fantasy environments, both with and without people. And I don't know about you, but I think these look pretty good. But those are pretty much all the takeaways that I have for these random batch prompts. So now let's get into manual prompting and exploring what these models really are capable of. Let's start with NetaYume. I think I'm going to dedicate proportionally more time to NetaYume than NewBie because after using both of these models for a while, I started to gravitate away from NewBie and towards NetaYume. Not only do I find it more intuitive to prompt for NetaYume, when I tried to do the same thing in both models, everything seems to work out better in NetaYume. The composition, the anatomy, the backgrounds. So just keep in mind that as I show you the capabilities of NetaYume, this also applies to NewBie. It's just that I was able to make things look better using NetaYume, so that's what I'm going to show you. Also, just keep in mind that there is more to it than what I'm showing you. I've generated a lot more images than what I'm showing you because these are uncensored models that do not safe for work content. I'm just not going to go over those aspects in detail here. Let's start with how to run it. If you're using Comfy UI, all you have to do is search the template workflows for NetaYume Lumina. It's my understanding that Forge Neo also supports running it. Neo is a branch of Forge Web UI Classic. I haven't personally verified that you can run it or if it runs very well in Neo, so if somebody has tried it, let me know in the comments. But for Comfy UI, I'm going to make a slight modification to the default workflow, and that's adding latent upscale, which will make the image bigger and a little bit more detailed. Now, remember the benchmarks we did earlier. Remember that inference time increases exponentially with resolution. So you might be tempted to upscale to huge proportions, but you're going to be waiting a long time. So I'm going with a modest 1.5x upscale. And that's really all there is to it for the custom workflow that I've set up for myself. It's all just kind of rearranged here into a single subgraph. I've pre-prepared a prompt here, and I'm just going to hit the run button and let it run in the background while I talk a little bit about how prompting works. I don't know if I would call this a prompt guide because you already know how to prompt. You just tell it what you want in plain English. Now, to me, the main strength of using any Lumina model compared to SDXL is the superior text encoding capability. For example, you can specify multiple characters and what they are doing independently, and for the most part, it keeps them separate. So let's dig into this example. I've chosen a couple of characters that are well represented in Dambaroo, so they are in the training set. They're from Gushing Over Magical Girls. Good anime. The manga's even better. We're going a little bit risque with this one, but I think if you're interested in these models, risque is what you want. I've separated it into 3 different sections, 1 paragraph for each character, and the 3rd section is kind of universal prompt and environment and background. I don't think there's any one correct way to prompt, but organizing it like this helps me visualize it in my head before I hit the run button. For each character, I've specified what they are wearing, what they're doing, and their location in space. One of them is on the left, one of them is on the right. The one on the left is supposed to be standing, and the one on the right is supposed to be floating in midair. I've also assigned different facial expressions. Now, if you're accustomed to prompting with newer image models like Flux and Z-Image, this should be nothing new to you. But older models like Stable Diffusion XL simply can't do this. Yes, there are workarounds like regional prompting, but those are essentially two completely separate contexts stitched together. And since this is a true anime fine-tune, and other things like chroma are really focused more on realism, I might be so bold as to claim that this is the most advanced anime model we have to date. At least it's the most advanced one that I've used and I'm aware of. If you're aware of a different model that's maybe not on the Lumina architecture, let me know. I would like to investigate it. But anyway, I think you get the idea. It's been a little over 2 minutes since I hit the start button, and our image is wrapping up right about now. So let's take a look at it and see how it did. We can see that this is generally correct. They're in the correct position, they're in the correct clothing, they have the correct facial expressions. There's only so much you can glean from one image, so I went ahead and ran a batch. Let me show you first some of the shortcomings. We can definitely see some concept bleed here where the attributes of both characters are not quite separated. And we even have an instance where there's a third character that was not specified. But I would like to emphasize that these errors are probably more the exception than the rule, and the model does do pretty well on the whole. Here are a few more images from the batch, and we can see that they are all more or less correct. I also ran this same prompt on NewBie. Interestingly, I think there are less instances of concept bleed on it, but the composition does seem to be a little bit less dynamic. And since NetaYume has a faster turnaround time per image, if we're talking about picking the best out of a dozen, it might be a wash with the higher error rate of NetaYume versus the slower generation time of NewBie. But overall, I think regardless of which model you use, it'll generally do what you want. Let's take a look at one more example, and we'll go with Haruhi Suzumiya this time. Again, well represented in Danbaru. And I've just said that Yuki has her hands in her pockets and Haruhi has her arm around Yuki and the other hand is doing the peace sign. And the background is a snowy residential area. In this prompt, I've used fewer words to describe each character's clothing, and that might have helped reduce the errors where the characters are wearing the wrong clothes because I didn't see really any instances where everything was egregiously wrong. Now, interestingly, on this one, I think NewBie had a harder time with the background, and there were several instances of doing concept sketches and manga panels. And you can see again in this comparison that the final result just looks a little bit less polished than NetaYume. I'm not quite sure how to crack the code for NewBie prompts. It reminds me of the earlier days of the Pony model for Stable Diffusion XL, where you had to really actually know how to prompt for it for anything to look half decent. And you might say, oh yeah, all you have to do is use these quality tags and these artists. But to me, if it's not intuitive, then kind of what's the point? But that does bring me to the next subject, which is focusing more on NewBie. The template workflow is easy enough to find, but it is a little bit unwieldy to use. I mentioned this before at the beginning, but there is a front end called NewBie Image Generator that you might want to check out. It uses ComfyUI on the back end, but it presents the prompting in a way that's a little bit more user-friendly. It is still essentially displaying the underlying XML structure in GUI format, so it's only so much better than writing the raw prompt yourself. Once you get used to it, it's not really that complicated, but it is awkward and tedious. In this example here, tags are laid out in a similar way that you would specify them in Stable Diffusion XL, but they are a little bit more organized. And this works if you're looking to lay out your image in a very structured way. But like I said before, I would much rather deal with a human-readable prompt in paragraphs. And fortunately, the text encoder is flexible enough for you to be able to do this. But you do have to switch it up a little from the defaults. You see, the prompting is actually a two-stage process. You're interacting directly with Gemma, a programming model that's actually pretty good at understanding human language. And Gemma actually outputs its structured XML to Gina, which processes the prompt. So really all you have to do is give it a template that says, hey, I'm going to give you a plain English description, perhaps some miscellaneous tags. Please reformat this into a structured XML based on a template. Granted, I don't style myself as a prompt engineer, but I think it works pretty well. In the off chance that you're someone who worked on NewBie image and you're watching me completely destroy your prompting system, forgive me. So that covers all the basics of using these models, but I've got one more trick up my sleeve, and that's adding SDXL to the mix. Modern illustrious models look pretty polished, so the idea here is that we take our output of Lumina and we run it through maybe a 0.4 or 0.5 denoising image to image and have a final gloss with SDXL. Naturally, there are downsides to this because if you push it too hard, you can lose the original context. SDXL, of course, doesn't have the same text processing capability, so if you have multi-character gens, you can start introducing more errors, you can get the wrong eye colors on the wrong characters, stuff like that. So let's take a peek under the hood of this subgraph and break down how it works. Now, XL prompting is a little different. You probably know that if you just pass in some human-readable sentences, it'll give you a suboptimal result. For the purposes of image to image, it would probably work if you just passed in the original prompt, but here I've elected to use an LLM to convert human-readable sentences into comma-separated lists of tags. Don't be intimidated by all of these nodes. This is just loading an LLM, instructing it to pick out attributes from sentences and output them as a comma-separated list. Some may argue that this is a little bit overkill, and some people may prefer manually putting in their prompt, but this only adds a few seconds to generation time, and it works pretty well for my purposes. But anyway, the important part is to process the Lumina output in image to image. I found that usually what works best is somewhere between 0.4 and 0.6 denoising. You want enough to be able to transform the fine details of the image while keeping the coarse details intact. And of course, after this, you might also want to refine individual segments like the face so that you can brighten up the details and make it pop a little bit more. But if you're used to refining images in InPaint, that's nothing new. All of this to say that if your Lumina output is missing a little something, you already have the tools to spruce it up. So with all that said, let's take a look at some of our final results. So the first thing I find refreshing is just the precision in which I can prompt. Like, I want the character on the left to eat a cheeseburger, and I want the character on the right to eat a hot dog, and I want a plate of French fries, and I want a napkin on the table, and I want the person to be holding the burger, and I don't want an extra burger on the plate or random burgers scattered throughout the environment. It's just good at getting the composition that you specified first time, every time. And the second thing I really like are the environment and background details. More so for NetaYume. NewBie tends to output kind of more basic environments, but on NetaYume at least, the scenery looks pretty cool. So, final thoughts. Are these models good and should you try them? I think that's going to depend on your expectations. If you're looking for a drop-in replacement to SDXL, this is not it. I consider these to be relatively obscure models that don't have a lot of user support behind them. So if you're used to something like SDXL where there's just a LoRa for everything, you're going to find yourself a little bit disappointed by this. And if I'm being completely honest, I think these models are just not ready for prime time. But if you like to experiment and you like playing with new toys, this is a cool thing to dive into. I've had a lot of fun trying to get these models to work and trying to coax the best results out of them. And I get it, that's just not for everyone. The state of these models right now reminds me of Stable Diffusion XL. Remember, it took over a year to get a polished-looking anime fine-tune, and the images I see coming out of NetaYume and NewBie remind me a lot of those early anime fine-tune attempts, like before Pony came out. So I'm going to continue to keep an eye on this. It has the potential to go somewhere. Maybe it'll get lost in the noise when Z-Image and Flux Klein start to get fine-tuned. But hey, that hasn't happened yet, and this stuff is here today. But anyway, I think this video's gone on long enough. I want to keep it under 30 minutes, so give this stuff a try. I will link workflows in the description. Thank you for watching, and have a nice day.